By the way, I've said that I get to the extension bits later, definitely not this video, because I'm not using the extensions at this point. I'll just check the documentations. Framing. I've talked about frames, which is the well-defined stream of some binary and textual data defined in the specification of WebSockets. Framing is a different concept, is how to split and concatenate and merge together a data. It's especially useful for large binary data, and it's using a continuation frame, so that's why I will get to this before I'll finish with the frame types. In the previous versions of WebSocket, you send textual data. So you send a message, and when you send data, it was the message itself. All the data was the message itself, except for the first and last bytes. When you want to split the large data into several parts, you have to have some application logic built in server and in the client. HyBi versions of WebSocket specification solve this on a protocol level, and that's framing. The framing means that you can send data in several parts. You can send one data in several frames. Let's say all you want to do is just transfer some big file from one endpoint, and on the other just save it. Imagine it's a video file. It can have 7 gigabytes of data. So on one side you will have to read all those data in memory and then stream it somehow using some mechanism to network, and on the other side you will have to receive it as one data from a socket and manage this whole data. So again, in case, for example, 1 gigabyte, 2 gigabytes of video, you will receive those data. You will have to store them in memory before you were able to save them. What framing allows you to do is to send few megabytes and say it's a binary data, of course, and let's say this is not a final frame. So the endpoint will, for example, create a file, push the data in it, and then it will receive a second frame sent by the client, and the frame will be defined as a continuation frame, and again, not a final frame. So the first was a binary frame and not a final. The second is a continuation of the previous, which means binary. And again, it's not a final frame. So you open the same file and append the data, and then you receive the third frame. Again, it's not a final, it's a continuation. So you will receive those frames that are not final and that are continuation, and you will append the data to a file. And at the end, you will receive again a continuation frame, which will be marked as the final, which is this identifier here. The type would be continuation, and final will change. So you can see this one large file in several parts using the protocol itself. Of course, the logic, the application have to know whether save it or process the parts independently or what to do with them, but the protocol itself allows you to handle and receive large amount of data. Or you can use it actually for streaming. Not at this point with the browsers. Browser doesn't support streaming. They will expose the data at once. But when you If you would have your native server and your native client, you will be able to use it for streaming of actual data. So for example, you will have a client that will open two connections, one for regular communication and second for streaming of data. Two, you have to open two because you cannot send any non-control frames, which mean another binary or another textual frame within other frame. You cannot open a binary frame and then send text frame. You can do this. You can send control frames like close, ping pong, but you can send another. So you can open two communication channel, one for streaming of data and the second for regular communication. You can do that. So again, for sending and receiving large data or for streaming. So I will show you the framing itself. What I have here, I can send, let's say I did for all three clients. What I have here in a server, I will send this text in 3 frames. I will split the text in 3 parts and I will send them as 3 frames. So what did I do? Let's start with I can do it. This is the first connection, which means it's a Chrome. As you can see, I've set 3 frames to Chrome, and the Chrome merge it into one message. So again, it can be used to stream a data. If you send really a big amount of data, it will be expressed to you as one data, a whole message, not just by frames. What I've did, as you can see, I've sent not a final, actual message with 5 bytes. Again, each textual message must be UTF-8, so when you're doing the splitting in textual message, you have to split on characters and then send this as a text. You cannot split it in the middle of UTF-8 character when it, for example, has 2 bytes. So I've sent not a final textual frame with 5 bytes. As you can see, this have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's okay. So I've sent not a final textual frame for 5 characters because this is ASCII. Then I've sent another 5, not a final continuation and 5, and then I send a final continuation and what was left. And on a client side, it was concatenated together, the same way with the Firefox. In a native client using Bauglir WebSocket, you actually do intercept those messages. As you can see, I've received free events, free read events. The native implementation within Bauglir WebSockets doesn't do the merging. You have to merge it yourself. It's actually pretty easy. You receive not a final and textual, so you start to cache any continuation frame until you receive a final. I've received the last received frame was the last 7 bytes of the message, but I've implemented here this caching of the continuation frame the first typed frame and the continuation frame together, so I can see the whole message. But what was the last I've received was actually this. Again, it doesn't matter whether I send the message from a client or from a server. In using framing. So again, this framing is used to separate one data into several parts, send it as separate frames, using first frame as a typed frame where you specify whether it's a textual or binary data, and then until the last frame, send all, including the first one, as not a final frame, and then from the second to the end, all are continuation frames. You can see the last was set as a final, the first set a type. Everything else was set either as a continuation, not a final, or continuation. So this is a concept of framing. Using a framing, I will show the last feature of a HyBi specification and Bauglir WebSockets, which is a sending of binary data.